Hello everyone, I am Perry, and today I will be teaching some vector math. The context for these lessons are for engineering practices. Vectors have direction and magnitude, and have different ways of being represented. The most common is Cartesian vector form. In engineering analysis, we won't exceed 3 dimensions, which are commonly called x, y, and z. Each of these axes are orthogonal or perpendicular to each other. At any location or point, has a x, y, and z component. In Cartesian vector form for 3 dimensions, a vector has 3 parts in the I, j, and k direction, which you can define but are most commonly aligned with the x, y, and z axes. A vector going from the origin, 0, 0, 0, to a point P with coordinates px, py, pz has the form vector v is equal to px I hat plus py j hat plus pz k hat. The hat symbol over the I, j, and k means that it is a unit vector and its magnitude is equal to 1. Unit vectors are essentially just the unit circle from trigonometry. Unit vectors are used to tell the direction. I hat is 1, 0, 0, j hat is 0, 1, 0, and k hat is 0, 0, 1. Angle brackets is called vector form and a shorthand version of Cartesian vector form. However, remember that vectors have both direction and magnitude. A vector's magnitude is a scalar number and is calculated from the formula. The magnitude of vector v is equal to the square root of the sum of its squared components. To a unit vector in the direction of a specific vector, divide that vector by its magnitude. When multiplying or dividing vectors by scalars, simply apply the operation to each component. Other ways to represent vectors, other than Cartesian vector form, is using its unit vector and scalar magnitude, or its angles and radius, polar form. Another way to describe its direction is with cosine angles, by displaying the angle between the vector and each axis. Doing the cosine of each of these angles will give you the unit vector. Vectors can be added or subtracted together by adding or subtracting each like component. Vectors can also be multiplied or divided by a scalar value. Simply distribute the scalar value. However, vectors cannot be multiplied together and have special operations to do so. The first is called the dot product, where vector v dot vector u is equal to a scalar value. This is the formula. This operation can be used to determine many things. The most common use is to find the angle between two vectors, using this formula. The dot product of two vectors divided by both their magnitude gives the cosine of the angle between them. So a vector divided with itself gives its magnitude squared divided by its magnitude squared, which is 1. A vector divided with the opposite results in -1, and a perpendicular vector results in 0. The cross product is another way to essentially multiply two vectors, but the cross product outputs another vector. I'll now show you a few different ways to do a cross product. First, numerically. A way to remember this, which will also help later, is the IJK circle. Say the operation following its order on the circle. In the correct direction, clockwise, it is positive. The wrong direction, counterclockwise, is negative. Another way is to use a matrix and find the determinant. Make a matrix with the first row as I hat, j hat, k hat, second row as the first vector, and third row as the second vector. For each unit vector, take the determinant of the 2 by 2 matrix that doesn't include them. J hat is negative. If you want a more in-depth understanding, see my linear algebra video. The final way I'll show you is geometrically. What happens geometrically when you use a cross product is you result in a vector that is orthogonal to both the inputs, and its magnitude is the area of the parallelogram that the two vectors make. That is it for the mathematics of vectors. Hope you enjoyed, and thank you for watching.